At our fingertips, we have one of the world's most influential pieces of technology, the smartphone. But what if I told you that your smartphone is made of elements that have its origins all the way in outer space? Come take a ride with us, where we will take a trip with the element europium from its origins in outer space billions of years ago into your smartphone today. 13.7 billion years ago, the Big Bang occurred, forming two central elements, hydrogen and helium. New elements were created with the rapid formation of protons and neutrons, like europium. The specific process that formed europium is known as R-process neutron capture, or explosive nucleosynthesis. Nucleosynthesis is simply the creation of a new star, an important producer of elements in the universe. Specifically, explosive nucleosynthesis is dubbed with an R to depict that it happens rapidly. Two neutron stars, which are those formed typically from the collapsed cores of a gigantic star, can collide and explode. Talk about rapid. So, a few explosions later, Europium is finally embarking on its journey towards Earth. Well, almost. The now complex solar system we know today was simply a large rotating cloud consisting of remnants of stars and very small dust. Within this dust lies Europium, and this rotating cloud that Europium was in eventually collapsed in on itself in response to yet another explosion from another star. Some gases merged into what is now the Sun, while others became solids and the building blocks for Earth. Zooming in on Earth, Europium now lies deep, deep, deep in the Earth's mantle. So, how does Europium get out of the ground? If in the mood for a swim, Europium can actually be found in the ocean. Europium can undergo partial melting to form magma, which is stored in magma chambers within the Earth. But these chambers are still very deep. Fortunately, there are little cracks that run from the seafloor all the way down to these magma chambers. When seawater interacts with this magma located here, this mixture gets shot up through the Earth in hydrothermal vents into the ocean. These chimney-like structures blast hot seawater mixed with nutrients, and of course europium, into the ocean, allowing Europium to finally be free. When maybe not in the mood to swim around thousands of feet underwater, Europium can break out of the Earth's mantle by being mined on land. The Earth is made up of tectonic plates, almost like humongous underground puzzle pieces that move along, above, or below each other. The Bayan Obo deposit in Upper Mongolia, China, where much of the world's Europium is found, is located above a subduction zone, where a denser plate of Earth is forced below a less dense plate. At the subduction zone, hydrothermal fluid reacts with a massive carbonatite rock and extracts europium out of it, which moves the element up via cracks through the Earth's mantle to deposits near the surface where it is easily mined and used by humans. A method used to mine europium is open-pit mining, which involves blasting rock, loading this rock containing europium onto large trucks, and transporting it to concentration plants. Once at a plant, a separation technique is used to obtain europium, known as solvent extraction. This process can be likened to making a cup of tea. When making tea, the tea bag is placed into a cup of hot water, where the compounds that give the tea its flavor and color are extracted, are taken out of the bag and into the cup of water. In mining europium, a solution is used to extract the element from other elements in monazite and bastnasite ores. Once purified in plants, europium is used in LED lights, fluorescent lamps, TVs, and yes, your smartphone. The pure europium complexes emit a red light when excited by energy from phosphors, producing energy at a wavelength to which the human eye appears red. So, when you were looking at that picture of a bonfire from your camping trip, or ordering those Nike sneakers with that iconic red check mark, the red color you see on your screen is thanks to europium. Recycling europium is still an ongoing area of research. Scientists are currently recycling europium from fluorescent powder in lamps containing the element, which can reduce the amount of europium that needs to be mined. However, recycling europium from our smartphones is still an ongoing area of research. Maybe you will be the scientist who discovers how to do it. Thanks for coming along on this trip of europium from outer space into the very phone you carry with you.